All right, welcome to The Explainer. Today, we're going to get into something pretty deep, a really fascinating link between beauty, reality itself, and, you guessed it, artificial intelligence. So let's kick things off with what feels like a modern day miracle, right? We've got these AI systems now that aren't just crunching numbers, they're discovering brand new mathematical formulas. I mean, completely from scratch. It really does feel like magic. But what if there's a hidden logic to it all? Yeah, these really powerful systems, like Alpha Evolve, they have this incredible three-step process. First, a generator just spits out millions and millions of ideas. Then a reasoner sifts through all of that, looking for patterns. And finally, a verifier comes in and proves that the new formula is actually correct, that it's universally true. So they're making this insane leap from just a little bit of data to a universal law. And the big question is, how on earth do they do that?
Okay, so to get our answer, believe it or not, we actually have to take a step back in time. We're going to meet a physicist who had this wild idea that beauty wasn't just, a nice bonus, but that it was the ultimate guide to figuring out reality itself.
And here he is, meet Hermann Weyl. This guy was an absolute giant of 20th century physics and math. I mean, just look at this timeline. His career covers some of the most mind-bending, revolutionary decades in the history of science. And through it all, at the very core of his work, there was this one incredibly powerful guiding idea. Weyl had this, pretty radical belief, and this quote just nails it perfectly. He said that the deepest truths about our universe are always, at their core, beautiful. And this wasn't just some poetic thought. It was a working principle that led him to breakthroughs that were literally decades ahead of their time. But here's the thing. For Weyl, beauty wasn't just, a pretty picture. It had a really specific technical meaning, symmetry. And for him, symmetry meant invariance. That's just a fancy word for something staying the same, even when you do something to it. Think of a sphere. You can rotate it any way you want, and it still looks like the same sphere. That's invariance. And Weyl was convinced that the fundamental laws of nature were just the universe's hidden symmetries.
Okay, so fast forward to today. What's so fascinating is how Weyl's gut feeling, his intuition, has actually been turned into a formal system. There's this really powerful modern framework for understanding how knowledge works called the theory of infinity, or TOI for short, and it pretty much builds directly on Weyl's ideas. So this theory starts with 5 basic building blocks or primitives. The very first one is called the unknown. Now this is the absolute ground floor of everything. Think of it as pure, formless potential. It's not empty space, it's a state before space, or time, or anything could even exist or be known. It's the ultimate blank slate before the slate is even made. Okay, so from that unknown emerges our second primitive, infinity. Now you can think of this as the very first thing we can actually talk about. It's this endless field that contains all possibilities. And because nothing has been picked out of it yet, it's perfectly uniform, perfectly symmetrical. It's like a vast, calm ocean with no waves, no features, just pure potential. All right, so we have this ocean of infinity. Now we need to do something to it. And that's where our third primitive comes in, the symmetry operator. Now pay attention here because this isn't a property anymore like it was for a while. Now it's an action. It's a process. It works like a filter, or maybe like a cookie cutter, that carves a specific consistent shape out of that endless uniform dough of infinity. But to use that cookie cutter, you need to press it down somewhere, right? You need a starting point? The theory calls this not infinity. I know, it's a kind of strange name, but just think of it like dropping an anchor in that endless ocean. It's a fixed reference point. It's the thing that breaks that perfect, featureless symmetry and creates a local context, a here, so you can start measuring everything else in relation to it. And finally, once you've done all that, you've filtered infinity using a symmetry roll from a fixed anchor point, you get your result. The fifth primitive, a golden set. This is the beautiful, elegant outcome. It's a coherent, stable, self-consistent structure. This could be anything, a proven math theorem, a law of physics, or really any complete, solid piece of knowledge. It's the solution. So all these pieces come together to describe this one fundamental process. You see it here in this canonical law. You take the raw potential of infinity, and you filter it through the lens of a symmetry anchored by a specific context. That's the not infinity. And what pops out is a coherent, stable structure, the golden set. This right here, this is the core engine of how things get discovered.
But here's the really cool part. That law isn't just a static equation you solve on a blackboard. Nope. It describes a dynamic, two-step process. It's like a cosmic dance that creates something real out of pure potential. And that dance has two moves. First, you have the twist. This is the creative explosion, the wild part. A moment where countless new possibilities are just generated out of thin air. It's chaotic and expansive. But then comes the fold. This is the opposite. It's a process of clamping down, of selecting and filtering all those wild possibilities against a rule of consistency, until only the stable, coherent structure is left. Okay, so now let's bring this all the way back to our AI. How does this cosmic dance of twist and fold explain how the AI performs its miracle? Well, this is the aha moment. This is where it all clicks into place. Okay, check this out. This table just lays it all out perfectly. The AI's process, it's not some unknowable black box. It is a perfect, real-world implementation of the theory of infinity. Just look at how it maps, one-to-one. The vast search space of possible answers, that's infinity. The rules of the problem, that's your non-infinity anchor. The AI generator spitting out ideas, that's the twist. And the evaluator that checks them all, that's the fold. And the final proven formula, you got it, it's a perfect golden set. I mean, just think about what's happening. The AI is exploring this infinite space of possibilities. The problem's rules provide the anchor. The generator part of the AI does the twist, creating millions of wild ideas. And then the evaluator part does the fold, rigorously checking every single idea against the rules. And what's left standing at the end? Only the final, proven formula, the golden set. So that incredible leap of discovery that the AI wakes, the one that feels like magic, it's not magic at all. It's a systematic, exhaustive search for a hidden symmetry, an invariant pattern that was already baked into the problem's structure, just waiting for something powerful enough to come along and find it. Okay, so this reveals something really, really profound. And it's not just about AI. It's about the very nature of reality and our place in it. It suggests that we actually share a kind of common ground with these new machine intelligences. What this theory is really suggesting is that symmetry is the bridge between what is, the structure of reality itself, and what we can know about it. In other words, the fundamental rules that create the universe are the very same rules we have to use to understand it. It's all built on the same foundation. And this is why it all matters so much. For one, it helps explain that old mystery of the unreasonable effectiveness of math, why math is just so darned good at describing the universe. It also gives us a shared language, the language of invariance and symmetry, for us humans to discover things alongside AI. And what it really suggests is that the search for truth is at its heart a search for beauty, a search for symmetry. Which leaves us with one last big question to think about. If symmetry really is this shared language, this common ground that both humans and machines can use to decode the universe, then what incredible new truths, what amazing new forms of beauty are we on the verge of discovering together?